Hi, everybody. My name's Jack Porter. I'm the Unreal Engine mobile team lead, and I'm based here in Korea. And today I'll be giving you an outline of some of the things that are up and coming and some of the very new features in Unreal Engine. 박수 안 하셔도 돼요. So I'm going to first discuss the release schedule for Unreal Engine and then give you an update about what we're developing. And of course, many things are going on in Unreal Engine, so I've focused only on the things that are important to you guys, Korean professional game developers. And I'll give you some rough timelines, like the Unreal Engine version we expect the feature I'll talk about to be released. But the caveat is that plans are subject to change and some of the work is R&D and things might get delayed. But I'll give you the kind of best estimate of when we think things are going to land. So the Unreal Engine release schedule, you probably know 4.23 was released in early September. We have a hotfix 4.23.1 scheduled for next week. That fixes a few critical bugs, one of which I'll talk about a bit later. 4.24 preview 1 is coming around the same time, around the end of October. There'll be more preview builds throughout November, and we expect the final release to land sometime in December. And then 4.25 will be sometime late in the first quarter of next year. And usually we expect it to be around the GDC timeframe within a few weeks. Of course, you can always go to the Unreal Engine Roadmap Trello website, but the difference between this and what I'll tell you today is this, because this is public facing, we only, it's very conservative about the information we give out, and it's only for features that are absolutely complete will be listed in the 4.24 list there. But it's worth keeping an eye on from time to time. So first of all, I'm going to talk about the large environment, open world game type features in Unreal Engine. And the first of those are some landscape tool improvements. We have a new layering system for non-destructive editing. And this is a bit like Photoshop layers where we can, you could have a base height field that was imported from a third-party tool. And then you can modify on top of that, and the changes you make are not destructive, so the original data is still there. We have a concept of custom brushes made with blueprints, and instead of just like a paintbrush on the terrain, this is blueprint access to the data in the landscape. So you can make, for example, you could place some buildings in the world, and you could build a blueprint in the editor that would find where the buildings are and then modify the terrain so that it meets the bottoms of each of those buildings nicely. We also have some spline, landscape spline editing improvements. The splines can modify one of those Photoshop type layers that I mentioned. So when you want to put a road and have the edges of the road fall off nicely in the terrain, that can be baked in to a non-destructive layer, so when you move the spline around, the height field will be modified correctly. And there's also some new editor key bindings and things to make working with splines more friendly. And we also have modified the foliage painting tool that allows it to place any kind of actor rather than just certain types of component. A bigger change to the engine is this is a virtual texturing system. There are two types of virtual texturing in Unreal Engine. There's streaming virtual texturing and runtime or landscape virtual texturing. In the video on the right, we are loading, the color is changing as we're loading more and more detailed sections of the virtual texture into the environment. just as a visualization. And 4.24 will have this out of beta as a production feature for desktop and console. Mobile is currently under development, and we expect it to land in version 4.25. So the streaming virtual texturing works by streaming very high resolution texture data from disk as it's needed. And this is similar to other virtual texturing systems, I guess you've heard of. And the way this differs from regular texture streaming is with texture streaming, you have a fixed texture, like a 4K texture, and then you can stream in like the 4K version or the 2K or the 1K or the 512 version of that texture as needed. But when you're up close to an object, you only need a small part of the 4K texture. You don't want to have the whole 4K in memory. So the idea of a virtual texture system is only the parts of the texture at super high resolution are loaded as needed. And this is great for much higher resolution light maps as well as unique surface textures throughout your environment. And you're limited just by the size on disk of your environment. More interesting for open world type games is the runtime landscape virtual texturing. This is production ready in version 4.24, and we are actually using it in the live version of Fortnite that went out this week. And the idea here is that instead of just loading some data off disk, we already have a material in landscape that, for example, a landscape material that blends a whole lot of layers together. And if you know anything about landscape materials, you'll know they're very expensive for computation, for GPU computation, because for every pixel, we're going through all the layers, working out which ones are relevant, and blending them together. And the idea with a runtime virtual texture is you take that material you've already created, and instead of rendering it every frame, you add a runtime virtual texture output node. And that node takes the output and stores it in the runtime virtual texture cache, which is just a bunch of texture memory. And so every frame when you render the landscape, you're just going to pull out that texture that you've pre-computed out of the virtual texture cache. And so as you move through the landscape environment, from time to time, you'll run the very expensive landscape shader to generate new data as you move into a new location. But hopefully the player is moving through the environment at a much lower speed than you need to be generating these new virtual texture pages out of the expensive landscape material. But in practice, we've seen this improves performance a lot, and we can have 10, 20, 30 layers easily, putting a bunch of decals onto the terrain to really add very unique road and unique blending for specific areas of the landscape. You can also blend meshes into the terrain in the distance. For example, you could blend some foliage into the terrain and have a very high fidelity version of that in your landscape texture. And as you approach, the object stops being blended in and you have the real object. We have a new atmosphere and sky model. This is physically based simulation of atmospheric scattering. And it supports, like, you could have a static mesh that's a globe of a planet, and when you're down in the atmosphere, it will render correctly. And as you move all the way out into space, the atmospheric scattering will be similar, with a similar density transitions that you'll find, in a real planet. Another advantage of this model is that we've made it accessible to the material graphs, and this means, so in the picture on the right, kind of the fog and the scattering is done by the atmosphere system, but the clouds are, nice artwork. But because we make the atmospheric parameters available and the results of those parameters available to the material in the sky dome, you can make the sky color and effects match the same fog and scattering that you've got in the rest of the sky. And this is super scalable. It scales from, it takes approximately 1 millisecond on an iPhone 6S. Dimitri, who did the last session, did a lot of work to optimize this system for mobile. And it's around 0.3 milliseconds to compute the lookup data on a PlayStation 4. This is just an example of some of the scattering parameters, both Rayleigh scattering and Mies scattering. It also has some artist control parameters. The next thing I'll talk about is some improvements to the procedural tools. In 424, we have some changes to the procedural foliage. As I mentioned before, it can place any kind of actor, but we can now also read from the landscape layers to control the density that way. This is not in 424, this is in an upcoming version, but we're working on some procedural scattering tools for placing foliage and kind of detail around the environment in a procedural way. So not just landscape or terrain, but on any kind of surface we'll be able to scatter plants and rocks and foliage with a configurable set of rules and kind of masks. Moving on to some miscellaneous areas, including performance. Apart from the Unreal Insights, which definitely helps look at performance, we're continuing to work on drastically improving streaming performance. We think moving through the environment and then the time to stream in data and add it to the world, especially the CPU cost, is very high at the moment. And so we're going to more efficiently package the data that we need to stream in and optimize the serialization of view objects. And finally, adding new objects, new components to the world. The registration part is a very large cost of that. And we're currently doing that over multiple frames, but we want to minimize that cost even more. Some more miscellaneous optimizations. There are major improvements to the performance of invalidation panels for Slate. This is especially important to mobile titles, because on mobile we often see Slate or UMG taking a large amount of the performance. We've got some blueprint virtual machine optimizations coming in 425 to make blueprints run more efficiently. And we're also working on improving the network replication cost, or reducing the network replication cost to reduce CPU time on dedicated servers. Obviously, as you scale to many, many users in the cloud, the CPU time is a direct cost, and anything we can do to minimize that is going to save you money. It's not optimization based, but it's a miscellaneous improvement we've been working on for a while, which is text-based assets. As you know, we have a UAsset format that's based on serialized data. That's a binary format. And we want to make an equivalent text representation for that data so that you can write tools to modify it and perform any kind of manipulation of your content. And so we now can go between the binary format and the text format and back again without losing any data. That's working. But at the moment, the text format we have is not really that human readable. So we want to reduce that complexity to make it much better than just a huge dump of XML or anything like that. And we're prototyping that with some simple asset types. Moving on to rendering, something new that's coming in 424 that we think is production ready, at least for consoles, is our screen space global illumination system. It's a fully dynamic GI system. It's quite expensive at the moment. We have not yet been able to reduce the cost to make it suitable for kind of mid-end, so really high-end PCs and consoles at the moment are feasible. It says there 2 to 2.5 milliseconds on a PS4 Pro. When you've got 16 milliseconds to render the frame, that cost is still pretty high. But we're quite happy with the quality. We're going to continue to work on performance. So this is an example of a scene without the GI, and then when you enable the GI, you can see both the GI bounce is occurring, and as well as bounce light, you're getting the bounce color. Bits of red are being visible on the left wall, for example. Oops. As an update to ray tracing, we're continuing to focus on performance and stability of this. We support a few more Unreal Engine primitive types, including now static meshes, which have their vertices modified by world position offset, can now be ray traced. We're supporting multiple views or stereoscope views, so you can, for very high-end VR visualizations, would now be possible, as well as some more Niagara particle types, including ribbons. We have a new global illumination algorithm for the ray tracing that's much faster than the previous implementation. So render graph is it's a way of inside the engine expressing the dependencies between different rendering passes, for example, base pass and translucency, or different parts of the post-processing chain. And the render graph knows what the dependencies are, so work can be done in parallel, and state change can be minimized. And so we've done this for post-processing. Future work is to convert more of the rendering passes to this new render graph API, and the render graph, we hope some of the results will allow us to collapse render passes together, or have more optimal transitions between different passes, so that if they're rendering with compatible render targets, we can merge those passes together, or at least avoid a switch of render target, which would cause, especially on mobile devices, will cause quite a lot of extra cost. The material systems had some random additions, one of which is the from material expression shading model. So this is, instead of specifying the shading model as part of the material properties, you can just choose from material expression and then add a number of different lighting model, shading model nodes to your graph. So you could add a regular lit one, as well as a automotive paint type, two-tone, multiple layer lighting model, and then you can blend those together. So in the example screenshot, you've got on the right, you've got an automotive paint type clear coat, and on the left, you've got a regular lit. And so this prevents the need for a second material section when you have a complicated, for example, a character or a character model material. Instead of having to break up into multiple sections, you can render it as a single section. Other material improvements include anisotropic materials. So for brushed metal or for hair, we now have this built into the engine. We have a new subsurface scattering model, which improves skin rendering quality and has a simpler setup for artists. So we want to bring the destruction feature of chaos out of beta in 4.25. If any of you were here yesterday, you might have seen Alan Noon's session on the new tools. So as well as improving those tools, we've been focusing on stability and performance. But chaos is more than just destruction. It's a full physics engine, and we're working to replace physics as the default physics engine in Unreal Engine 4. And our target is to do that sometime next year. We have support for scene queries, overlap checks, which allow some very interesting game code interaction with the physics engine. And of course, we're going to have to support cloth and vehicles and all the other things we're currently relying on for physics. We don't have any chaos support on mobile at the moment, but we expect to have basic destruction features working in 4.25. So Niagara, again, we're focusing on performance and stability, but we're using this in production. Many of the effects in Fortnite are now using Niagara. One thing missing is GPU simulation for mobile. That's in development, and we're targeting that for 4.25. We hope to have all of Niagara out of beta as being a production feature for 4.25 as well. It's something we haven't shown before is we're working on some new hair tools. Previously, games would have to use, some sheets around the head to simulate both the physical properties as well as the rendering of the hair. And the results were not very good, especially for longer hair. We have a new strand-based approach where we are simulating individual hair strands. And we have a mass rendering technique that ends up generating geometry in a kind of cross formation for each hair strand. The focus right now is comparing our visual results to kind of offline hair rendering solutions meant for kind of the animation industry. And we hope this to be practical in real time on high-end PCs. We're going to optimize this to high-end console, in the future. At the moment in 4.24, it's an experimental feature. So if you're looking for forward-looking future games and you want to see what's going to be possible, please take a look at it. The last section I'll talk about is mobile. And first of all, for iOS, there were a number of things that needed to be changed for iOS 13 support, mostly on the packaging side. And those fixes are in 4.23.1. The other thing we've been working on a lot recently for iOS is the ability to build Unreal Engine as a framework. And if you know anything about iOS or Unreal Engine on iOS, you'll know that kind of Unreal Engine is the app. So, as soon as you start the app up, Unreal Engine is running, and it's the packaging and the way the project is built is all controlled by, Unreal Engine and Unreal Engine properties. But the idea with this framework option is instead of Unreal Engine driving the app, we have the app as a single standalone standard Xcode project. We have a template, but once you start, you're going to keep that Xcode project and configure it how you want it, using the standard iOS development processes and practices. This lets you configure code signing how you want, use custom views, use the user interface builder, all of the tools that a regular iOS app developer would use. You can use those tools. You can target Apple's features such as sticker extensions. And then you can use Unreal Engine as a framework. And when you want to start Unreal Engine, you can just start it rendering on a single view that's a part of that standard Xcode project. And if you've downloaded the latest version of Fortnite for iOS devices, you'll see that we don't enter Unreal Engine straight away when you launch that game. We, in fact, bring up a fairly standard iOS-type app with some user interface controls, and it's got some social features. And then when you choose to launch the game, it will update the content and launch the game. And that's built using this framework, same framework idea. On the Android side, we've been focusing on app bundles. They're a new feature, a new format for the Google Play Store, where instead of uploading a final APK file, you upload a bundle of different resources that Google Play Store puts together and makes an APK targeted to the particular user's device, for example, based on the texture format or 64 versus 32-bit device. So we have a new project setting to enable that, and this creates an app bundle instead of just the APK. But as part of this process, we do generate a universal APK, which is basically all of the bundle together in a single APK that you can use for local testing or for launching from the editor. From 4.24, we are also raising the minimum spec for Android to be OpenGL ES 3.1, so we're dropping ES2 support. We've looked at the top 100 devices around the world, and there's only a very small handful of devices that do not have ES 3.1 support. Our reasons for doing this are several. Firstly, we can rely on compute shaders because they're a core part of the OpenGL ES specification. And many of the new features that I talked about, such as virtual texturing, have some components that can rely on compute shaders, as well as Niagara GPU particles. Also, the number of texture samplers are available. The 8 available for ES2. We're always using 3 or 4 for Unreal Engine, so it was pretty impractical. And importantly, we now have feature parity across iOS and Android, as the minimum capabilities of the devices are pretty much the same. And it simplifies the rendering code a lot. And so the trend we're seeing in emerging markets for new devices, even very low-end, low-cost devices, is they're taking a very capable GPU design and just giving 1 or 2 cores or a small number of cores. So they're saving costs by reducing the complexity of the core that way instead of using a very old core, which was the previous approach. So now we're getting some quite capable, feature-wise, some quite capable GPUs. They just have very low power. One area we're also working with our partners on, including Samsung, is to provide better performance when the device is being thermally throttled. So as you probably know, when you play a game, the device gets hot, and that causes the device to slow down. And so if we can get information from the device saying that this kind of situation is occurring, we can take action before it happens and prevent it. So we can look at our current CPU and GPU workload and the device temperature, and we can scale the game's parameters using the scalability system. We can drop quality levels, and we can drop resolution until the device has stopped overheating. And we're hoping to get this in experimental state in 4.24, but 4.25 plus, we expect it to be more production ready. Refresh rate on new Android devices such as the Pixel 4 has been improved. The 90 Hertz refresh rate is very interesting to us because the standard refresh rate is 60. So now that we have 90 available, we can sync to every second VSync, and that gives us a 45 frame per second option, which is pretty good, where maybe our content can't sustain 60 Hertz on a particular device. Having 45 as a fallback is much better than falling back to 30. Of course, we always want to enable VSync on mobile devices because it gives, if we don't enable VSync, we're just going to maximize GPU utilization and very quickly overheat the device. So syncing to a lower rate lets us give the device a chance to cool down. Some miscellaneous improvements. One I wanted to call out that went into 4.23 was a refactor of the event handling on Android. So Android operating system gives us some notifications that we need to respond to. And there were always some problems with this implementation, especially early during startup. For example, playing a startup movie while loading. If you would rotate the device or background the app, there would often be stability problems related to this. So we refactored that code, and now when you background, everything suspends correctly and recovers very nicely. And this looking at the Fortnite crash statistics, this got rid of a large amount of our crashes were people who started the app and then decided they wanted to background while it's loading, for example. And we reduced the crash rate a lot. I'm going to talk about what we call GPU scene, which is the auto-instancing feature of Unreal Engine. This came in 4.23 as part of the high-level rendering refactor. And the idea here is that we store all of the data that individual primitives need. So if you've got a number of trees, you need to store all the parameters that are different between each instance of the tree. So the scale and the location, as well as other parameters, such as the object radius, that could be looked up in a material. If we store that data in a large buffer, we can access that data from any draw call. And that allows us to merge multiple draw calls together. So as I said, this shipped in 4.23, but on mobile, we only supported it on iOS and Vulkan Android. On OpenGLES, we had some problems with Mali devices because there were some buffer limitations that meant it would crash if you tried to use it in larger scenes. We have an alternative method in 4.24, and this will be a supported feature for mobile. I have to say that with Fortnite content, we're completely GPU bound because we have a lot of content. And if we ask it to draw 100 trees, whether or not we're asking it to draw 100 trees in one draw call or 100 draw calls, the GPU is still doing the work. And so if we're limited by the GPU performance, the instancing doesn't help us improve frame rate at all. So this is best for scenes where you have a lot of instanceable content, or you've designed your scene to be well instanced, and therefore your render or RHI thread bound. And finally, I'm going to talk about the desktop forward renderer. And we think this is the future for high-end mobile. In fact, we use it on the Nintendo Switch for Fortnite, which is not exactly a mobile device, but it's a handheld device. We think this renderer could be suitable for very high-end iOS and Android devices. The high-quality forward renderer is a forward plus renderer that supports most of the lighting features of Unreal Engine in SM5. And on PC, we used it for Robo Recall, and as I said, Fortnite used it on the Switch. We've previously shown this working on iOS hardware for a small tech demo, but we've never shown it in production. So we're going to look at getting this to be production ready in the 4.25 and beyond timeframe. And we plan to add support for Android running on Vulkan as well. So thank you very much. That's the end of the roadmap session.